All right, now that we have these velocity vectors under control, what we want to do is we're going to take a look at how we can use these to control the orientation of our normal and up vectors that are down the line going to control the orientation of our instances. So let me hit the D key here, and I'm going to turn off V, but turn on up, and I'm going to turn on normals. Because remember, we had set these in our initial particle source. So you can see, though, if I turn on my vectors, we can see that those vectors are there, but they don't change over the course of the particle. They're staying static. So if we put a piece of geometry on this, it's just going to kind of hold in space and not look like it's moving sort of with the direction of the particle movement. So we have the initial vectors there, but what we need to do is make sure they get oriented based on the velocity vectors. Okay, so this is what we're going to do. We're going to make another point VOP. And I'm going to call this rotate n and up by v. Again, just human readable stuff, so it's really clear to know what's going on inside there. Color that green. And now let's dive inside there, and I'm going to show you the process for this. So what we're going to do is we want to align everything to the incoming velocity vector. So I'm going to make a constant, just a vector with a value of 0 across the board. Now I'm going to use an align node, and I'm going to align from that 0 vector to the incoming velocity. And now we're going to use an extract transform, plug the matrix output into the transform input of this, and we want to, from the extract transform, we want to extract rotation. So you can see that we have transform, rotation, and scale extractable out of here. And so what we want to do now is I'm going to do a transform matrix node. Okay, so what we're going to do is we're going to use a transform matrix node, which you'd often use actually just to like move or translate or rotate geometry, but we're actually going to use this to rotate vectors. There's a lot of different ways to do this stuff in Houdini, and there's obviously, you know, sort of more advanced vector math kind of stuff. I'm just trying to show you a really straightforward way to be able to rotate vectors based off of other vectors. So what we're going to do is I'm going to feed the normal into the input of this transform. And then out of this extract transform node, I'm just going to wire the rotate into the rotation. And now we're going to do the same thing with the up vector. I need to import that point attribute because that doesn't come in off our geometry VOP global. So I'm going to say we want to import vector 3, first input, and it's going to be called up. And then I'm just going to copy and paste this transform matrix node. We're using the exact same thing. So this, now instead of feeding the normal into the position input, I'm going to feed the up vector. And now at the end of this, the transform output, the first one is handling the rotation of the normal, so I'm going to feed that into the normal. And the second one is handling the rotation of the up vector. So I'm just going to do a bind export. Hit the P key, make sure this is a vector, and rename it to up, all lowercase, close the parameter window, and then wire this into that. So this is just like a really straightforward way to rotate these two vectors which we need for object orientation by this velocity vector coming in by just using this align and extract transform combo. Okay, so now let's look at the output of this, and you can see even as I switch between these two different nodes, you can see that our orientation has changed, but we have made sure to orient our normal and up vectors together so they still stay perpendicular, so it's still a proper sort of orient pair. All right, so now as I watch these birth out, we can see that now these objects are following the movement of that velocity vector. We can see they're coming out, they're flipping over on this edge, and they're coming down. And now at the end, once they hit their final points, they aren't, you know, darting around and rotating around. They're moving around a little bit, but the rotations are staying static, so we're not going to get any annoying jittering there. Cool, so now we've tamed our velocity vectors and we've used those vectors to control the rotation of the normal and up, so we can have really clean, established rotations of the objects that we're going to instance onto these points. All right, so just some useful overall vector techniques, and again, making sure that we have all of these attributes under control under the hood, so we always can make sure that we can control how our objects are going to be positioned and oriented. Okay, so next we're going to move on to tweaking the velocity once again to have it be proper for our final result.